Saxon's Trig, lesson 121, is about the piecewise functions and then greatest integer function. We jump right into example 1, in which they have us to write the equations for, so this one starts at -1, it gives me a dot here, a dot at 1, so that part is straight, and I don't want that to look like an open circle, it's definitely colored in, and then at the 3, they graphed a 1, and they connected a slanted line there, and then they do a straight line from here going forever. So we call this a piecewise function because it's in 3 distinct pieces: a horizontal line, and a slanted line. And they're looking for the equation for that function. That means I need to have a series of 3 different equations for this particular graph. So if I start with this one, it's a straight line and it's horizontal. It's crossing the y-axis, which means it will be y equals, and at what number did it cross it? -1. Here's the new part. Where did I get this? From which x values? From 0 up to 1. So I have to clarify that this is the formula if 0 is, the x is greater than or equal to the 0. Again, I'm writing it backwards, so I had to stop and figure out the way I'm saying it and the way I need to write it. And it must be less than or equal to the 1. Now this or equal comes because I had colored in dots. That's why I said it's very specific. I didn't mean for that to look like it was an open circle. If it had been, I wouldn't have the or equal lines. Now this piece is a slanted line, so it's filling into the format y equals mx plus b. So if it's easy enough, I might be able to count my slope and figure out where I cross the y line for my b. If not, then I need to fill in these dots as helping me find the b. So let's see, rise of 1, 2, run of 2, or rise of 1, run of 1. Either way you figure that out, it's coming up, the slope is 1. So I know I'm going to have equals x. And now, again, I said I might be able to estimate where that b is, although I don't like to guess. This one, because I can count it, because it's down 1, backwards 1, it's going to land at -2. So I can do that without having to stop and fill into the y equals mx plus b formula and use like 1, -1, or 3, 1, and then solve for the b. Either way, we still have to clarify that this is for values between 1 and 3. So x has to be greater than or equal to the 1, or less than or equal to the 3. Now, this works and it's fine, but technically I have a dot here, which tends to throw students because they're like, how can I have it in 2 different formulas? And you just have to follow whatever it is. If it's a solid dot, you're putting it here for this graph, but it matches the same, it's okay because it makes it work for this formula as well. If it didn't, then I would have to have an open circle, and then I'd kind of have to figure out which one does it work for and which one does it not work for, and that would get the equal sign or not get the equal sign, just depending. All right, and then my last one is, again, a horizontal line, so it's y equals, and at what number does it cross the y-axis? Well, technically at 1, but what values is that for from 3 and above? So that's if x is greater than or equal to 3. And you've got that same argument. It's a colored in dot, therefore it works in both, so it can be or equal to in both. Now, example 2, write the equation for this given function. Oh, and this one is so much harder to draw. Okay, so 6, 1, 2, 3, 4, 5, 6. They have an open circle here, straight arrow going across. Here they have a dot at 0, 0, and then they have a dot at -8, 7. Ugh. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And there. And so it's very nice that they went ahead and clarified that that was negative 8, 7. And it says write the equation for this. So I know that I have two different parts, two pieces. So we're going to have two different equations. Horizontal one, y is crossing at, what did I say, 7? 6, 1, 2, 3, 4, 5, 6, sorry, 6, if, and that is when x is more than the 0. So x has to be greater than, not or equal to, because I have a circle here, 0. And then on this one, I will be able to use my or equal to. So it's very clear which answer, which equation this dot works for. It does not work in this one. Hopefully that's making sense to you there in my clarification. Now, the other one is slanted. So we know it's fitting into y equals mx plus b. Again, I would count my rise over run. So I'm rising 7, running 8, which makes my slope 7/8. And if I picture, is it positive or negative? I picture the car coming from the left, it rolls downhill, so I know that this slope is negative 7/8. You can also say I went up 7, backwards 8. That also tells me it's negative. I still need to know my b. Oh, wait, it's perfectly clear. It's 0. Hallelujah. I don't need a b for that, but I do need to clarify my if. So it's things when x is less than 0, but or equal to because of the colored in line. So there's the equations. All right, example 3. Now it's different. Now it wants me to graph the given equations. So it tells me that I'm going to have a y equals 2, a straight line. I'll write this out so you can actually see it. And the boundaries here are from negative infinity, and that's that sideways 8 looking symbol. So from negative infinity up to or equal to the 0. So coming from negatives indefinitely up to the 0, I will have a line at at 2. Sorry, I wrote positive 2, but I didn't think that was right. Yeah, at 2. Okay, so here's our 2 coming from the negatives up to this point and stopping. It was or equal to, so it's colored in and going, oh, sorry, that went slanted there, but now I think you get the idea. The next part says y equals x, so that's going to be like plugging in 0, 0, 1 gives 1, 2 gives 2, so I know it's going to be a line of some sort. But where are my bounded numbers? This says between 0 and less than or equal to the 2. So at 2, I would be getting a dot of 2, and it's colored in. At the start, 0, 0, it's not. So it's open circle on this one, and then my line connecting. And the last one says y equals 3 minus x. So this is like the flip-flop of y equals mx plus b. So I know that I'm starting on the y line at 3, technically. And I don't know whether I actually have a dot there or not, because I've not looked at my boundaries. I'm just kind of getting a picture of what this line does. And then I would do a slope of rise 3, run 1. So it looks like I've got a line going this direction, but where am I bounded? I should be starting. Just a second. Why is that going the other direction? Oh, goodness gracious. It would be because that's negative x. It's starting at 3, yes, but it's down 3 because it's reversed. It's doing this. But I'm bounding it from 2 to infinity. So, you know what? I would probably actually plug in the 2 to this formula. 3 minus 2 is 1. So when I do 2, I actually am starting at 1. And because I said I'm not or equal to that, I'm going to do an open circle here. And I know that that line was then heading this way because I said it was coming off the 3 and it was going down. So I'm going to do a line coming off of that Or from here, I can count my slope, the down 3, forward 1, however we want to get that thing graphed. Now we've done that. Now, part B is greatest integer function. And you see this very weird looking graph that is the greatest integer function. I'll show you what the graph looks like, and then we'll talk about what it means. I'm not going to do a whole bunch of these, but I will do one down in the negatives. There we go. Okay, so this is like a stair step, and my dots should be at 0, 0, 1, 1, -1, -1. But what I'm saying is that every fractional piece in here is stuck at 0. Every fractional answer in here is stuck at 1. But because I have the colored in dot here, I can't have it here, therefore it's an open circle. So it just looks like steps going up or down, depending. But that's what the greatest integer function means. You are stuck at wherever the start was. So for this one, it's at 0. You're stuck at 0 until you get to the next integer where you pop up to 1. You're stuck at 1 until you get over to here, then you would pop up and you would get 2, and you're stuck at 2 until you get to 3, and so on. That's why it's greatest integer. You're stuck at your greatest integer. And they introduce that, and then later on they manipulate it. But I should point out that when you are asked to graph that or use the greatest integer function, it is given to you this way. And it's not an absolute value. It's more like your matrix, except that it's only one number. So that's how you shouldn't confuse it with your matrix symbol.